Question 3. Okay, so what we've got here is a velocity time graph of a race for the final 10 seconds. Velocity time graph. So we see that the first 4 minutes, first 4 seconds of the last 10 seconds, the person is moving with a constant acceleration because there's a constant gradient. The second section, which is from 4 seconds to 10 seconds, they're moving at constant speed, so there's no acceleration at that point. So I've written that down. 0 to 4 seconds, constant acceleration. I've worked it out. 60 divided by 4, 15 meters per second, because the gradient is the acceleration. And from 4 to 10 seconds, there's no acceleration, and I can just see that the speed remains constant at 90 meters per second. So I've described that motion there. Now, show that during the final 10 seconds, the distance traveled is approximately 800 meters. Now, how do we get the distance? It's a velocity time graph, so the area underneath that gives us the distance. So I've split the area out. So this section I've called A, this section I've called B, this section I've called C. So that area there is 6 seconds times by 90 meters per second. So 6 times 90, which is 540 meters. Then this section here is 30 high, 4 wide, and that's 30 times 4, which is 120 meters. And then we've got 4 again times by, then that distance that there is from 30 to 90, so that's 60 meters per second. And because it's a triangle, it's half times 4 times 60, which is 120 again. Add all those distances up. 540 plus 120 gives you 780 meters, which is approximately 800 meters. Now, part B, okay, key idea here is very, very easy to kind of get muddled up with the words. Initially, when I read this, I did get muddled up with the words, and I was of the inclination that the graph should start off at 0 just and then go to 10 seconds. But because it says use the axis below, sketch the graph showing how the distance of the motorbike from the finish line varies with the time during the final 10 seconds of the race. So what you're saying is that the distance that is measured is not, it's from the finishing line. Okay, so what we are saying is where the finishing line is at 800 meters, or we've calculated 780 meters from the starting point. So the final 10 seconds, we know that we are 780 meters from the finishing line. Okay, so distance from finishing line. So we know in the final 10 seconds, we have traveled 780 meters. So we are 780 meters from the finishing line. Okay, so, and we end up at 10 seconds, 0 meters from the finishing line because we're at the finishing line. So we know we've got to start off here and we've got to end up here. Okay, so start off here, end up here. So 10 seconds to go. We are 800 meters, 780 meters from the finishing line. And then at 10 seconds, we're at the finishing line. Okay, so here we know that the first 4 seconds, the distance traveled is 120 meters, 240 meters. That's the area under this section. That's the distance traveled. Okay, so if we start off at 780 and we have traveled 240 meters, so we will end up 540 meters from the finishing line at 4 seconds. Okay, so that point must be on your graph as well. So now I know that the object is accelerating from 30 meters per second to 90 meters per second. How do I draw that? How do I draw acceleration on a velocity time, on a distance time graph? That the gradient will show us speed. So if I'm going to show acceleration, my gradient should increase. So I've kind of started off a little straight and I've curved it to that point. So the gradient is increasing. Now, the 4 seconds to 10 seconds, we know that the speed is constant. So our gradient must be constant on a distance time graph. So that is our straight line. Now, this question in itself is a difficult question because we are looking at this graph and we are mapping the speed over time by looking at the gradient and making the link. Okay, so we know it's a constant speed, so there must be a straight sloping line and a acceleration, and that should be an increasing gradient. Okay, and that's where the marks are. You have to get these 3 points in a straight line in this section and a curve increasing gradient in the second.